of solutions product management for VMware. It means I develop services and I focus really on all three of our technologies, our technology layers, CAP, SIM, and EUC. Prior to that, I was the manager of our worldwide energy computing practice team. So I spent a lot of time at customer sites and working through lots of trouble, doing a lot of enterprise architecture work with some of our biggest customers. And I fixed a lot of problems over the time. Spent a lot of time with big implementations that stalled, helped customers get going again. So what I've attempted to do with this presentation is to bring a lot of that knowledge, a lot of that experience. It's a little bit technical and it's a little bit common sense. So hopefully what you'll see is the advice that helps you either implement Vue or help your customers to implement Vues. So just a very quick survey. By a show of hands, who works for a customer who's here with a VMware customer? Okay, so good number of you. Partners? Show of hands. Excellent. Europeans? Good. Just making sure everyone's paying attention. I work in our corporate headquarters, although I'm based out of New Jersey. Of course, you know VMware is in Palo Alto. But I feel like I live in Palo Alto because I'm there quite a lot for meetings, so I fly back and forth. So I get to meet a lot of our engineers, talk directly to our product managers. And so if you have any challenges, any questions that you want to make sure get all the way back to Palo Alto to get to corporate headquarters, so please feel free to mention them to me. All right, so let's get started. So there's a standard disclaimer on all of our presentations. I'm not going to be talking about future products today. I'm going to be talking about the here and now products. Vue 5 primarily in my session today. I've been delivering a version of this presentation for a couple of years now. I've been really focused on Vue deployment, Vue design methodology. And I found that the discussion is quite difficult unless you already understand how we scale Vue to very large implementations. So another quick show of hands. Who already has Vue deployed or knows a lot about Vue already? Okay, great. I'm in the right place then. Awesome. So what I'd like to do is start by talking about how our Vue architecture scales. And in particular, if you've seen our reference architecture, you know that we talk about 10,000 users as a way of describing Vue at very large scale. So I'm going to explain how we get to 10,000 users and what that looks like. So to begin with, we start with a Vue pod. Vue pod concept is very simple. Basically, one connection server makes a pod, makes a Vue pod. It's our database, if you will. A pod contains all of our entitlements, the user entitlements. We entitle users to pools. And so a Vue pod is the term we use to describe that cluster of Vue connection servers. So we've got that oval underneath. That means that is the replicated cluster. So that's the Vue pod. The Vue pod is our first basic building block. There's a few other building blocks we're going to show you. Our next building block is called the block. It's the Vue block. And this is how we partition our physical resources. So the Vue pod is a logical construct. It just means the connection server database, that cluster. Vue blocks are how we start mapping users to pools. And so what you see here is I've got 5 blocks inside this Vue pod. So that's the pod and block architecture. Again, these are still very logical partitions. A desktop pool is contained within a Vue block. And desktop pools, because they're constrained by vSphere clusters, it means a desktop pool doesn't span blocks. So it's contained within a block. Making sense so far? So when we're talking about building, designing, and scaling Vue, I have another logical partition to introduce you to, and that's called the Vue management block. The idea around the view management block is that I keep all of my server infrastructure related to view separate from the physical resources that my desktops consume. So the thinking behind the management block is, if you were going to do disaster recovery, you would do DR of the management block. On the pool side, we would just recreate the desktop pools on the failover location. Is this making sense so far? So next, I introduce some of the physical components, or the vSphere components. So a view block is delineated or separated by the vCenter server. We do this for a couple of reasons. The vCenter server is what controls the desktop provisioning. I create VMs, I destroy them. It also is in charge of power on operations. So the view connection server talks to a vCenter server and says, go create me 1,000 desktops. And then vCenter has to do the work working with ESX. So by delineating the block by the vCenter server, I create an opportunity to scale horizontally all my power on operations and my desktop provisioning operations. Otherwise, what I would be asking one vCenter server to do is to create me 10,000 VMs at once, which would take a very long time. Everybody knows that in vSphere, a vCenter server, vCenter server 5 can manage up to 10,000 VMs, right? But you don't want to do that in View, because View puts a lot of strain on a vCenter server. It's a lot of requests. Provision, power on, power off, restore, snapshot, etc. So I put my vCenter servers in my management block, because as I said, I use my management block as a DR boundary. I want to make sure that of the infrastructure that I want to recover, I want to make sure that my connection servers are first on the list, my vCenter servers are next on the list. Also, you can see here, I've got the ESX servers up inside the view block. Again, the view block aligns to the vCenter server, and so that's where my physical resources live. And finally, I've got my storage and networking components here. The interesting thing about storage is, several years ago, we thought that the storage conversation with View was all about footprint. But we found out later it's really not about footprint, is it? Can anyone tell me what's more important than disk size when it comes to size of the SAN for View? IOPS, absolutely. And so here I'm showing that the storage could be shared across View blocks, or it could be dedicated to a View block. I also should add to this diagram and show that you can have several SANs mapping to a View block. So hopefully this makes sense. You could see, some storage appliances like EMC and NetApp, for example, have some great SAN appliances that are quite powerful, and they could span multiple blocks. Most of the time, though, what we see is that View generates so many IOPS that we end up dedicating one SAN per block. We scale View to about 2,000 users per block. You can go a lot larger than that. This is not a limit. This is just a recommended architecture. If you go above 2,000 users, we're really asking a lot of vCenter server. A lot, again, desktop provision, destroy, power on, power off. As I mentioned, the View pod is an administrative boundary. This is where our desktop entitlements are kept. This is an important database because this is where the desktop pool configuration lives. So we refer to pod and block as this architecture design model. And the pod, you really can't put your finger on a pod. You can kind of put your finger on the View block because there are real resources, there's real infrastructure there. But the View pod is just really a concept. It really just refers to the cluster, the connection server cluster database. The provisioning boundary concept, something I already touched upon before. What we want to do is keep a reasonable number of provisioning operations to each vCenter server. So you don't have to scale this way. If you were going to build, say, 2,010 users, you could certainly have 2 blocks and put 1,005 users in each. So it's not like you always have to fill up one view block and then move to the next view block. If you were going to get to 10,000, in fact, we have several customers who are at this phase. If you know that you're going to eventually scale very high, you could start by building out 5 vCenter servers and then scale upwards. And again, the view management block is just about creating a separate cluster of resources that are server workloads that I like to keep separate from desktop workloads. So up on the top in my view block is where I run my desktops. We know that the workload characteristics between desktops and servers are very different, right? We know that server workloads are very consistent, very average, and desktops are very bursty. They do a lot of this. So we want to make sure we don't have our slow, steady server workloads interrupted by desktops that are doing this all day long. So we keep them separate physically, and this way it makes it very easy for us to provide disaster recovery. So does this concept make sense? Yeah. Hopefully it's a little bit easier to understand. I used to present all of that in one slide, one picture. Had a lot of lines and circles on it. I tried to make it a little bit easier, just special for VMworld and EMEA. So the next concept I would like to introduce to you, this is a term that I made up. I call it design decision entanglement. And it's a very important topic when we're designing View for the enterprise. So I'll try to explain it like this. We know that one of the critical decisions we have to make when deploying desktops is what operating system to deploy. Now Microsoft is trying to make this conversation easy for us by saying you can't deploy XP anymore. But some of our customers still like XP. XP works pretty good, right? So some customers are trying to decide between Windows 7 or Windows XP. Eventually, we'll be deploying Windows 8, and then we'll have XP 7 and 8. That'll be helpful. But to start with, we look at the operating system decision, and we evaluate how important that is to the overall equation. And that's what I'd like to walk you through right now. You might think that it's just one of many very important decisions, the choice of operating system. But I would tell you it's the most important decision to make at the start of an engagement, if you have that option, if you could decide to do XP or Windows 7. The reason is this. We know that operating systems need memory, right? Some operating systems need much more memory than other operating systems. Like Windows XP, you could get by with half a gig. Windows 7, at least a gig, maybe 2 gig. So what do we know about memory in virtual machines? Is there any storage that we have to account for when we're assigning memory to virtual machines? Does anyone know? My VCPs? For the vSwap file, right? So we know that the decision I make in operating system leads me to a decision in memory, because I would never give half a gig of memory to Windows 7, right? No one here would do that, of course not. So we wouldn't do that, so we know that if we decide to go Windows 7 over Windows XP, we need double the RAM. We also now have to account for the extra storage that we need for double the RAM. So fortunately, those vSwap files can be put on the local data store. It means it's cheap. If you don't do that, you can use memory reservations. Memory reservations can impact my scalability, because maybe I can't run as many VMs on ESX as I would like. So it turns out that the relationship between the operating system and memory is also directly associated with the storage. Of course, we also know that Windows 7 has a very large storage appetite compared to Windows XP. Does anybody know the difference between a very slim XP build and a Windows 7 build in terms of storage gigabytes? Anyone? No? I know, it's a scary question. So the difference is about 8 gig for Windows XP and about 20 gig for Windows 7. It's a very, very big difference. We could get Windows 7 down to about 15 gig by taking out a lot of services and things like that and optimizing. But before you know it, Windows 7 goes right to 20 gigs. So the minimum partition that I would ever deploy for Windows 7 is 22 gig. And even still, that's a very, very small amount. Something else we know about operating systems is they need CPUs. Windows XP runs really nicely with one CPU. Windows 7, depending on what you're doing, you might decide to do 2 CPUs for your new desktops. So now we have to account for that. Finally, the whole point of installing an operating system is to run applications. And so, quite conveniently, it turns out that a lot of application vendors are saying, well, when you upgrade from XP to Windows 7, we want you to upgrade to the new version of our application. I'm sure many of you have run into this before. It's time to not just pay for all the costs of the licensing for the desktop and all the consulting work and the new PCs that you need for the latest Microsoft operating system, but now you have to upgrade all of your applications. And by the way, we have a product for that called DynApp, which is great. Unfortunately, I think it's like VMware's best kept secret. I don't think we talk enough about DynApp, but it's a great thing for running applications on Windows 7. Okay, so now we know that the operating system choice is associated with application choice. And it also turns out that applications consume CPU, applications consume memory, and so we look at how important and critical that operating system choice was. If we make that OS choice first and we get it done right, then the rest of our decisions are much easier. And so here's the key design principle that I'd like to share with you. Highly entangled decisions must come first in the process. If I started with storage first, I might make a whole bunch of other decisions, and then I land at operating system and I realize I have to fix all those decisions that I made because I had the wrong inputs. Hopefully this makes sense. So I would like to show you the view design methodology. I know it looks like a giant wheel. There's a couple of things that are going on here that I'd like to point out. We start up at the top of the wheel. That's the big play button that I put up there. And we step through each of these slices are phases of the project. So we step through all the phases and we get back to the top of the wheel. And then we think to ourselves, well, we're not done yet. We have to go through one more time and consider all of our design decisions in context with the other decisions that we made in the process. And I do that, and it's very important. It relates to this key design principle. Highly entangled decisions come first. If you look here on the right side of the wheel, we have persona, desktop, and pool. We come to this phase and we design our pools, and we target our users, and we figure out how are we going to manage user personas. And by nailing that decision, getting that decision right, we have an idea about how much storage that we're going to need. You notice on the opposite side, when we do storage design, we might run into a scenario where the budget or maybe customer requirements drive us to choose maybe an SSD on local ESX as our solution. And that may shrink the size of my pools. If anyone has read our white paper on our technical marketing site, then you realize that we have the reference architecture for view on local SSD. And this is a scenario where, excuse me, this is a scenario where we've actually run into this ourselves. The choice of SSD to keep the cost low meant that we had to go with a smaller disk. So after we designed our pools, we realized our pools were too big and we had to shrink them down. And so this is an example of if I just went through one time and I made all my design decisions in isolation, then I would have made a big mistake in either my storage design or my pool. And then when I went to deploy the infrastructure, I might find that I have a big problem here because I can't fit all these desktops on my ESX servers. And so that's what I mean by going through the design process twice. The first time we go through, we take inputs, we get requirements, and then we make decisions. The second time through, we double check all the decisions that we've made related to the decisions we made in earlier phases. Hopefully, does this make sense? Yeah? No? Yeah, all right. Very, very quiet audience. I'm not used to this. In VMworld Las Vegas, everyone's excited, talking back to me. You say, yeah, good job, John. Yeah. See, a little prodding, and you guys eventually come around. Okay, so If you'll notice, the first phase here is use case definition. And as my style, I think that the use case is actually the most important thing. I consider use case very, very important because that's how I decide which users I'm going to deploy for, which users I'm not, in scope of view or out of scope of view. And if I make a mistake with my use case definition, what do you think happens? I have very frustrated and angry users. Or I have a project that's too small and I missed opportunity. Maybe I could have brought iPads to more users and instead I only had a very small number. So I spent a lot of time thinking about doing use cases right. And I have really two different ways to define those use cases. And this is the new way. This method is actually borrowed from product management, which is my new role. And that is that I define the use case in terms of jobs, outcomes, and constraints. Now, I assume many of you here, you support users, yeah? Quick show of hands. How many people actually do user support? Yeah, so there's a lot of you, so you'll probably understand. We really like our users, right? Our users are really likable people. They do not know what they're doing. I think if we ask them, well, what do you need on your desktop? They're like, I don't know. And that's not helpful for us when we're trying to design a new desktop to replace for them. So we have to talk to them in a language that they understand. And I find that breaking the discussion down into jobs, outcomes, and constraints is a conversation that I could have with a user that's very helpful, as opposed to, do you use any devices? No, I don't use any devices. Well, what's that microphone attached to your desktop? Oh, yeah, I use a microphone. Okay, do you use any other devices? No, I don't use any other devices. Well, what's that scanner over there? Oh, yeah, I use a scanner. We love users, but they make us crazy, yeah? So instead, the conversation I like to have with my users is, okay, tell me about the work you do. What jobs do you do? Okay, so I work in finance, so I create spreadsheets, and I print reports, and occasionally I get receipts in, they have to be scanned in, and I create a PDF, et cetera, et cetera. And I say, I write all that down. What I'm writing down is the requirements. I'm hearing the requirements through the description of the jobs that they do as users. So once I get all the jobs from them, then I can turn to outcomes. And I can say, okay, so I assume you want your new desktop, your brand new View desktop, to be better than your old desktop, right? And usually they want it to be better. So I said, well, what could we do if you could make your desktop better? How would you do it? What would be different about your new desktop? Let's say you went to bed tonight and a miracle happened overnight and you came in and you loved your desktop. What would be different about that desktop? It's an interesting question to ask them. And they say, my desktop, it's very slow for logging on. I log on in the morning, I type in my credentials, and then I go and I get a latte, or I get a cup of coffee, or I go have breakfast. And I come back and I look and I say, yeah, not done yet. And I go away and I come back again. That's an outcome that we can change. That's an outcome I can understand. So you want your logons to happen faster, is that right? That's right. So that's a conversation I could have with them. But if I try to ask a user, well, how long does your login script take to run? They usually have no idea. They're like, oh no, it's really fast. Okay, can you show me logging in? Yeah. Your logon script's taking 2 minutes to run. It's like, oh yeah, that's that black box. That black box takes 2 minutes. They don't know it's a logon script. So instead I asked them, what can we do different about your desktop? How can we do that better? That's the outcome that I'm interested in. And finally, I care about their constraints. What works, what doesn't work? And some constraints are good. Some constraints are, are you able to use your laptop when you're driving in the car? Do you have a Wi-Fi connection to your laptop? No, I don't. Okay, that's good. So what other things are constrained? Or maybe in the perspective of what can't you do that you would really love to be able to do? Maybe you would love to have a single sign-on for multiple devices. I go home, I use a browser, I log on, I get my applications. I come to the office, I log on, I get my applications, same data. And so this is a way of defining more requirements through the constraints. what can't you do, and maybe what would you like to do. Does this make sense? There's another way of thinking. You know, so the point is that users rarely know their requirements, but they know what they do and what they would like to change. I think this is pretty straightforward, right? Pretty simple. Usually, we follow a different model for doing user segmentation. I think that there's the simple model, which I'm going to walk you through, not in too much detail, because by attending the conference in a couple weeks, you can download the presentation and you can have it. You can look at it at your leisure. So we care about things like use case attributes, workload characteristics, and connectivity classification. And I think this is the way that most consultants and most companies have been doing their user segmentation for some time. There's another way that's really interesting, my friend Brian Gamage introduced me to, which is user segmentation by 4 parameters, which is mobility, autonomy, business process, and collaboration. So this is a Gartner model. I wish I could give it to you, but it doesn't belong to me, it belongs to Gartner. But it's a really excellent tool. So I would recommend, for those of you that have access to a Gartner account, go find and download their user segmentation model. It's really, really excellent. If you don't have a Gartner account, then find someone who does. Very helpful. So this is an example of simple user classification. We care about attributes. These are attributes like, are you a standard worker? What's your location? What time do you use your desktop? What devices do you have, et cetera, et cetera. Like I said, a whole list here that you could review offline. You look at the 2 attributes at the top, workload category and connectivity classification. These are pretty interesting, so let's look at these a little bit closer. When we consider workload categories, this is very similar to what we were talking about maybe 2 years ago when we had power users and task workers, etc. And back then, the conversation seemed to be more about user density than what it is today. And I think it still is about user density. How many users can we get per server? But it's over time and not on day one, not immediately. And I'll explain what I mean. Task workers generally don't install their own applications. They generally don't do their own IT support. They don't install things like device drivers, and they're not fooling with the registry keys and whatnot. And so usually we give them very limited privileges in the operating system. We don't let them install apps or devices. These sessions tend to have a few apps that they run consistently all day long. So like I said, a couple of years ago, the conversation seemed to be that if we had task workers, we could probably get more task workers on a server than we could power users, because power users are doing powerful things. They're running big applications. They're very, very busy. But I think actually task workers use more CPU because they sit down at their desk and they do this for 8 hours. They work very hard. Well, maybe they take lunch. So they do this for 4 hours. They take 30-minute lunch, and they come back and they do this again. What do power users do? Any power users in the audience? Anyone been to a meeting? If you've been to a meeting, you're probably a power user. Because I think that power users go to meetings more than anything else. You log in, you get your cup of coffee, you send an email, and then you walk away for 2 hours in a meeting. And then you come back. Lately, I feel like I attend so many meetings that I think my job is to convert air into carbon dioxide. I just change breathable air. That's what I do. A lot of talking. So, power users, in my opinion, are very bursty. We use a lot of CPU for a little bit, and then we go away for a couple hours. The difference between the task worker, the standard worker, and the power user is really what happens over time. So power users are powerful. So we need to install applications. What happens when we install applications? Windows starts to rot. It rots from the inside out. The more apps I install, the more device drivers I install, they all need to be patched. Hot fixes come down, more apps installed, more devices. Eventually I have to go and say, I need my Windows OS refreshed. I need to reinstall it. So I would say that over time, the impact of power users who are able to install apps and install devices and make changes is that you get fewer power users on your ESX servers. Your density starts to go down and go down and go down. Task workers, you could deploy 100 users on a server, come back in a year, and you're still running 100 users. With standard worker or power users, if they're making changes, and I install a server with 100 users on it, and you come back in a year, and maybe I'm down to 80 users, you come back in 6 more months down to 50 users. Because over time, these changes are causing Windows to rot from the inside. Does this make sense? Sorry, does this make sense?
Yeah.
Yeah, all right, great. So next we talk about connectivity. On the connectivity, I really only consider 3 things: low bandwidth, local mode, or LAN. In the low bandwidth scenario, I'm trying to focus on latency. Has anyone tried out the new PC over IP in View 5? Quick show of hands. Yeah, it's great. Really great. We've seriously reduced the amount of bandwidth we consume. This means that now we have more users who want to connect from long distance. So we want to make sure that our display protocol is going to work well over that low bandwidth, maybe high latency situation. So we want to know that going in. I want to understand, where are you going to log on from, user? You know, when you do your job, are you doing it from the office or are you doing it from home? Maybe this brings it back to a constraint. I can only do my job in the office. Okay, I understand that. Now I know I don't have to worry about tweaking PC over IP to cope with high latency scenarios. Or maybe the opposite. Maybe we need to accommodate high latency. Local mode, of course, there is no display protocol users working local. And LAN scenarios are good to know too. So I put all of these things together into a connectivity classification. So now I've gotten my customer requirements defined, and now I'm going into my use case definition. So this is where we start to think about all of these things coming together. We try to take all these requirements and make as many standard pools as we possibly can. Can I combine different types of users together because they have the same requirements at the core? Maybe finance and marketing use pretty much all the same applications and devices, and they're all task workers, and so I can put them in use case 1. And then IT has very different demands, a lot of power users, a lot of devices, a lot of Windows rot, so I'm going to put them in use case 2. I'm going to figure it out that way. Making sense? Yes. So I exit out of my use case definition, and now I can start targeting. This gives me the volume of users. How many users in my population are use case 1, and how many are use case 2, and use case X and Y, and on and on. That gives me what I like to refer to as a meta pool of users. It's a big pool of users. I'd call it a pool, but it's confusing because we have desktop pools in View. So I have a meta pool of users. Let's say 10,000 of my users they all fit into use case 1. But I can't have 10,000 users in one pool. So I know I have to split up that pool. So now I start to think about my pool design. And this is the phase that I call persona, desktop, and pool. I put these 3 together because of the impact that persona has on this design decision. Of course, if I use a virtual profile, as opposed to the Windows local profile or Windows roaming profile, no one really uses Windows roaming profiles, and if you do, please stop. That enables me to extend the pool to more use cases. So let's say I'm dividing my use case up, and I find out that the user does not need to install applications. By not installing applications, maybe I can give them a non-persistent pool, and give them a floating pool. And I can capture their persona, which is, in essence, their maybe printer settings and their shortcuts and their favorites, their bookmarks in their browser. I could stuff them in the profile, in the virtual profile, and now I can assign them to a floating pool instead of having to assign them to a persistent pool. So it turns out that persona discussion is very critical in pool design. After that, we focus on operating system and virtual hardware. And of course, local applications. Try as we might, we cannot virtualize all the applications in the world. There's some constraints that we know about, like we don't virtualize device drivers. But there's some applications that are just either not well designed or just resist virtualization. So here in this design phase, we make the decision to either install the application in the operating system or virtualize it, or maybe do without. These requirements drive some design decisions, and now I know how many floating pools I need, how many dedicated pools, maybe local mode pools. Maybe I'm going to go with non-link clone pools because I have users who install their own apps and rot their own windows and do all that kind of stuff. Also in this phase, I consider the applications very carefully. And fortunately, we're seeing a lot more SaaS applications deploy into the enterprise. At VMware, at least 34% of our business critical apps are SaaS-based. So there's a lot of growth there. So at this phase of the design, now I'm considering what's the long list of applications that I need to account for in my Vue deployment. Which ones can I package with Dynap or some other virtualization products? Not that there's any good ones out there. And how else am I deploying applications? Am I using SMS, SCCM, or some other deployment methodology? I'm very happy to say that display protocol conversations, courtesy of Vue 5, don't occur quite as often as they used to. It used to be that I would have to make a very serious determination of which two protocols should I use, PC over IP or RDP. Now, fortunately, PC over IP has gotten really very robust. The feature set is great, it works great, and so PC over IP is the default choice in almost every conversation. It's almost to the point now where I stop having the conversation about display protocol. Thankfully, thank God, I'm very happy about that. After I complete all of these steps, I now have my pool design all mapped out. I know exactly how many pools I need, what the size of those pools are, and where all my users are going to fit in terms of use cases. Then I turn to the physical resource considerations. This is pod and block that I showed you about earlier. So as you know, the pod is just a logical instance. What's also something very interesting about pod design is that at VMware we do not support stretched connection server instances. That term may sound interesting to you. What we don't support is splitting a connection server across WAN links. And that's because our connection servers are very, very chatty. They talk to each other constantly. And the more connection servers we add in our design, the more conversations occur. So that's why we recommend that customers deploy up to 5 connection servers that are active. You can add 2 more for redundancy purposes to bring the total number of connection servers up to 7, but not to go higher than that, and not to split those connection servers across a WAN link. When you split connection servers across a WAN link, the messages start to queue up on either side, and they can't update one another very quickly. And that becomes a problem that's visible to the users, because the users go to log on, and they get the desktop not available, or some other visible errors. So the choice around pod then becomes more about where's the user and where's their closest data center. So I need to consider, am I trying to split up pods for BCDR purposes? Am I trying to distribute Vue pods closer to users so that they don't have to go across the ocean to log on, for example? And that's generally my networking discussion. Are most of my users located in Bangalore, but my data center is in Cork, for example? The pod is also a security boundary. That's where the desktop entitlements go. So let's say you were designing for a scenario that you had super high confidential data or proprietary or personal data that's in one set of desktops, and then you've got a more generic pool of users, say finance or maybe administration. We want to make sure never, never, never will I accidentally deploy a desktop or entitle a user to the confidential pool, the confidential data. One way that I can accomplish that is 2 separate pods. And I say, okay, I have admins over here that manage this super confidential pod, and then I've got my other admins on this side. So consider the view pod as a security boundary. And as I mentioned earlier, the blocks, the view blocks, are about scalability, orchestration, automation, etc. So here's where I start to lay out the pool types on top of the block. I consider administration. How am I going to manage the ESX servers, for example? And provisioning frequency is the number of desktops that I'm going to create, destroy, power on, power off, etc. Now, having designed all my logical bits, having collected all my user requirements, now I'm ready to start the real fun, which is start to get into the physical infrastructure. So here's where I design vSphere. I take my pod and block design and I lay it on top of vSphere. And I figure out how large is my management block, how many security servers and connection servers I need, what other infrastructure. For example, load balancing is something that we don't include in View. Maybe we should, but we don't. And load balancing is essential to very large enterprise designs. We have a few white papers for integrating View with existing load balancers like F5 and Cisco solution, etc. I also want to build out my block physical resources. And this is where it's very, very important to get it right. The desktop scalability numbers come from the right amount of RAM, the right amount of CPU in my servers, and especially the right amount of network connections. Wherever possible, I'd love to see you deploy using 10 gig Ethernet on the back end as opposed to gigabit E. Not because of display protocol demands. As I said, we've got some great efficiencies in PC over IP now. More because of the back end storage connectivity. So I want to make sure I'm seeing either fiber channel or 10 gig E connections to my storage array, because View is very, very hard on storage. As you know, it's all about the IOPS, and it's very bursty. So it's not like one steady stream of a lot of I/O. It's no I/O and then a big spike and then no I/O again. So it's important you've got the right amount of networking and, of course, the CPU and memory to drive scalability. And so I put storage in its own phase. And that's because for every time I jumped on an airplane to solve a customer problem, I eventually found that the most important place to look was the storage array. And that's because initially we made the conversation with storage about footprint and not about IOPS. And so we learned with a couple of customers how deadly that can be. This View really, really crushes the storage. So we put storage in its own category. Of course, we have to consider that we've got different storage demands. It's not just for the operating system, for the virtual machines. So we've got a lot of different things that we should profile. And I would strongly encourage that you have a little bit of a separate storage infrastructure for your management block, because that's the infrastructure you can use SRM to protect. You can do storage replication. You can make our View infrastructure highly available across BCDR scenarios by focusing on the management block. On the repository side, there's lots of different demands for storage. Like I said, it's not just about the operating system disk. There's also home directories that we have to account for, persistent disks, profile stores, transfer server needs are a little bit different than standard link clone demands. Golden master templates, and of course application repositories. And here specifically, I'm talking about packaging your applications in app and putting them on a CIF share so that I can keep those apps out of the virtual machines themselves and I can stream them into the memory state. I think that I could probably, in fact I have, spend an entire hour talking about storage. Of course, I don't have that kind of time today. But the point that I'd like you to take away from this slide is focus on getting the storage right. A couple of vendors I'd love to see you talk to while you're at the show. Nexenta is has a great, interesting software caching appliance. And Atlantis Computing similarly has a great storage caching appliance. And they are really helping us accelerate our View deployments. They do that by taking some of the cost out of the storage part of the design, and they make the storage work very, very fast. I would also encourage you to go visit Xigo, X-S-I-G-O. They're out on the floor. They have a really cool hardware network switch. So really great partners out there we're talking to. So finally, now we want to turn our attention to the edge, to the users' desks, or their laps if they're mobile users. So this is not necessarily an entangled decision. And in other words, no decision I make in storage design impacts my thin client design. But nonetheless, it's a very important one, and it's one that when you forget about, then you have that uncomfortable realization that, I forgot to put the device at the end user desk. I hate that. So some of the things to consider here is what version of operating system are you going to run on your client device? The right choice can bring along some pretty interesting things, such as I've got a client that has a soft phone that they run on their Wise thin client device. They run it alongside the View client, not inside the View client. So they're running the View client and then alongside of it the soft phone. So sometimes interesting solutions like that can be possible with the right operating system. Of course, you want to think about monitors. Something about monitors. Users really love looking at them every day. Otherwise, they just can't do their work, right? It's also an opportunity to make users happy about the choice to go to View. At VMware, we deployed View and we gave people thin clients. One of the ways that we incented them was we said, okay, we know that you're used to using PCs. We want you to use thin clients, and maybe you're a little bit nervous about it. I'll tell you what, we'll give you 2 24-inch monitors to go with that thin client. No problem. Everyone's ready to convert in that stage. And I swear, some of these monitors, they're just so big. I think if you had a picture of the sun, you could just sit down and just do some suntan right there. Just lay out in front of these enormous monitors. Other thing to know about thin client devices, even zero client devices. There's still software there. Even our Teradici zero clients, they have firmware, which is a kind of software, of course. So you always have to think about how am I going to manage all these devices out there. It's not as bad managing Windows desktops for certain, but you still need client management in your design. Okay, does this make sense? Yeah. All right. So what I wanted to do is transition from design methodology to implementation best practices, or I like to call them the hard lessons that I've learned, that VMware has learned over time. I'd like to talk about related design decisions. These are things that maybe we should have thought about at the start, but didn't. The first is migration. That's my geese flying south for the winter. Migration turns out to be a pretty interesting conversation, especially in View design, because sometimes when we think about how we're going to migrate to View later, we might do something a little bit different. Like we might deploy virtual profiles like a Liquidware Labs Profile Unity or an AppSense or a Res. We might do that on existing PCs first as a way of making it really easy to migrate to View later. When I do that, actually that persona discussion comes up again, doesn't it? And so then that might change my pool design. So we think about migration up front. Specifically, I like to encourage folks like yourselves to think about data migration. Users keep a lot of data at their desktops. I don't know why, but gigabytes of it. So we want to make sure if we're going to take that desktop away, we've got the data that exists on it to give back to the users. Otherwise, they get very, very angry. We also want to think about security. I love this picture. Makes me laugh. Every time I look at that picture, I wonder which came first. The camera or the monitor? Best of all, wouldn't it be great if that camera was working and someone came and stole it? You get a guy like, oh my God, there's a camera behind this TV, dude. So consider security up front. Anybody check out the security presentation yesterday? There's plenty to know about desktop security. We're making plenty of mistakes today in security. When the presentations come out, you should definitely search out this presentation. Jim Weesey from our Office of the CTO did a really interesting thing. Preparing for his security presentation, he set up a honeypot and put it on the internet. I think everyone here may be familiar with the term, but basically he put an unprotected virtual machine with a public IP on the network. And it had been discovered within an hour. Of course, he didn't advertise it. He didn't invite people in to come attack his virtual machine. But it was discovered in an hour. And then it became immediately obvious that he was being attacked by a massive botnet organization that was attacking from places like Afghanistan and Russia. And it took no time at all to know that they had connected to a View desktop and they were using our own APIs to try to brute force their way in. Bottom line is, don't add security as a second thought. Oh, maybe we should secure these desktops when we go to View. So think about security up front. Don't wait until later. Next, consider your administration needs. Will it be easy to request a desktop? Will it be easy to deploy a desktop? Or will you end up making it very, very difficult? And believe it or not, this is a related design discussion because if we don't think about how we're actually going to deploy desktops to users, then we might end up making that very, very difficult. Finally, we want to think about support. How will we be supporting these users? Users can get really confused when they have a virtual desktop. And help desk people can get really confused too if they don't exactly know where that desktop is. I know where the monitor is, I know where the user is, but where's the desktop? I don't know. So let's consider these things up front and incorporate them into the process. I'd also like to point out that it's important to consider the constraints in your design. More than once, I've seen consultants run into trouble with customer quality demands. We see this in the United States a lot around regulated industries. Is there something in particular I need to do about ensuring a commissioning process, for example, baselining, things like that? We also want to focus on knowledge. So View is different than your standard desktop. So what are the training, what are the education steps that we have to go through? Well, we have to educate users so that they understand a little bit different how their new desktop works. We have to educate the help desk. We have to make sure that we're sending people who do the administration to training to make sure that they know how to use View. We also, of course, should consider standards. There's a big bank in New York City that thought it would be a really good idea to buy UCS servers for View. And it is. It's a great idea. The UCS platform is awesome. Cisco is an excellent partner. The problem with this bank is that they standardized on HP servers. So instead of talking to their data center team, they just went out and bought 10 racks of UCS gear. And so the UCS gear showed up at the loading dock, and the data center guys go, I don't know what that stuff is, and I'm not putting it in my data center. And so those 10 crates of UCS gear are still sitting there on the loading dock, not in the data center. Why? Because they did not consider the impact of standards on this decision. Simple thing, right? But there's a lot of UCS gear for sale. If you're interested, let me know. And finally, we want to consider budget. It's just a really, it's the world we live in today, right? We need to make sure that we're considering budget. Mostly, we want to make sure that we're not forgetting the sneaky things, like the Microsoft licensing. You know, where am I and what device am I using? Because it turns out that that's quite important in terms of licensing demands. We also want to make sure that we get that storage budgeting done right, because some of the worst conversations that I've been involved in is customers who spend probably 6 figures on a SAN, and I watch the SAN fall over because we drive too much IOPS to it. And I say, I know it's a very difficult budgeting exercise you went through to get that $100,000 for that SAN, but I need you to go ask for another $100,000 for that SAN, because that SAN isn't strong enough. And so we want to consider the impact of the budget. Is the budget big enough? It usually isn't. Okay, so next I wanted to move on to some very specific technical best practices. Now, these technical best practices, again, it's not too deep technical. We will not be editing the registry in this presentation. But these are the things that come up time and time again. There are just a few things that if every customer and every consultant got right, then adoption would be very, very fast and very, very easy. In accounts and situations where it is done right, it is very, very easy. And adoption does happen very, very fast. So we're going to talk about 6 operating system optimization steps. And these all seem pretty basic, I know, but time and time again I see people who make them over and over. We start with the SCSI controller for the Windows device. So make sure you use either the LSI logic, the SAS, LSI logic SAS or parallel driver, and not the bus logic. I've been working with VMware technology for a long time. So I ran into the bus logic versus LSI logic, SCSI hardware issue back when we were talking about servers. So I thought everybody knew that you never use bus logic adapters. Turns out, not so much. So make sure that you're using the right driver. Next thing is to use the VMXNet 3 driver. So this is optimized in vSphere 5, and it makes a significant difference in view deployments. Don't just go with the default driver that comes in the operating system. That would be bad. Trust me. We also want to make sure that the VMware tools are installed in the operating system. Again, it's all about optimizing and accelerating the virtual machine performance inside of vSphere. Want to make sure that we're running at least virtual hardware version 7 or the latest. I think we might be up to hardware version 8 now. Want to make sure you're running the latest hardware version. And also, I think perhaps it goes without saying, make sure that the view agent is installed. And in fact, this problem is not as bad today, but we want to make sure that the view agent is the last thing that we install, because there was some conflict between the VMware tools and the view agent. So if you install the agent first, and then you install the VMware tools, we would break the SVGA driver. So, word to the wise, make the view agent the last thing that's installed. And then last, make sure you're doing NTFS alignment. This really comes up when we talk about Windows XP, not Windows 7. Windows 7 is aligned by default. Failing to do the NTFS alignment basically means that we're splitting IOs to the storage. So I already warned you that view is very hard on the storage. And when we double the IOs, it's doubly hard on the storage. I'd like to take a moment and talk about antivirus settings. Antivirus is really, really interesting, because I think that in terms of resources consumed, antivirus is the #1 enterprise business critical application. Because antivirus seems to consume everywhere I look, everywhere I have user experience problems. I see antivirus consuming about 30% of the resources. And so when you consider that you might have just spent $1 million on your corporate infrastructure to run 10,000 users on View, and I don't know that it would even come anywhere near that much, when you start to think about 30% of that number just for antivirus, it's a very, very large number. So I think that these are common sense things, but not so much, not always. So the first thing, if you're using link clones especially, turn off full system scans. I still see some companies out there that are trying to deploy View, and they have their antivirus agent, and their standard policy is we do a full system scan every night. All files all the time, boom, every night. That really hurts the SAN a lot. Especially consider in a link clone scenario, I've got a base image that's read-only. So once I deploy that image, it can't be changed. So why am I scanning all the files in there over and over and over again, every time, millions of times? I think it's just to stress test the SAN, or maybe the SAN administrator, I don't know. This next recommendation is a little dicey. Not everyone really likes hearing this. And the security team, I can understand feeling a little bit nervous about this. My recommendation is to turn off on-demand read scanning. Again, in a link clone scenario, this is far more applicable. But I've got a read-only partition here. So how about I scan it, then deploy it? Now I don't have to reread every single file in here, because all my link clones are all loading the same file. So if I scan it once, it's no different if I scan it 1,000,000 times. It can't be changed, it's read-only. So we don't need read scanning of those parent virtual machines. What we do need is, we need on-demand write scanning. because that's how viruses propagate. We know that they transfer, they load themselves into memory, they infect another host, and then they persist. And the idea of persisting is so that the next time you reboot, you go, oh my god, I have a virus. You reboot, it loads itself again. So make sure the write scanning is turned on. If you were just able to do that, you'd save a ton of resources in a view deployment. But better than that, go to the latest and the best antivirus scanner that takes advantage of the vShield powered, the VMsafe APIs. Because here's where we really get efficiency. We turn that 30% number down to a very, very small number. And that really makes a lot more sense to me. And as I mentioned, antivirus scanning consumes about 30% of resources in most view implementations. It's really pretty scary. Some storage best practices. Forecast your workload in advance. And I would say share that with the SAN administrator as well. I love to see SAN administrators who think, well, you know, these are only desktops. You're not going to generate that much I/O. I work with Oracle databases. You just have these little desktops. And then View comes in and absolutely crushes the SAN. So we want to make sure we use a tool like Lakeside Software, Systrack, or Liquidware Labs, Stratosphere. Use that tool, measure the workload inside the desktops, and then do some forecasting that way, so that you have some idea how you're sizing your SAN, because it's about performance, not about size. Size matters, but not so much in View storage design. And I think I've stressed this quite strongly. It's about IOPS and not footprint. And so long as you remember these two things, the rest of the storage architecture is pretty easy. I think it really just comes down to that. Know what kind of load you're going to put on your SAN before you put it there, and design for performance and not for size. Okay, a couple of tips on PC over IP. I like to try to keep it really short, really crisp. I'm seeing customers who think UDP is an unimportant protocol on the network, and so then PC over IP performance is terrible. So treat PC over IP like voice over IP. What we like to say is that, you know, like VC over IP, PC over IP is a UDP-based real-time protocol. We need those packets to arrive. If we lose one packet, we lose a few packets, that's okay. It's UDP-based. We're not going to retransmit, but we do need the packets to arrive. And more often than not, by default, enterprise networks are configured to treat TCP like the most important protocol on the network. And so we want to make sure that UDP gets its fair shake. The advice is to make PC over IP one step in importance below voice over IP. We don't want to mess up phone calls, but we want the display protocol to make it through the network. This is a really technical recommendation. This next one is to, in congestion management, configure your network to use WRED and not tail drop. These are just congestion management techniques. So WRED is weighted random early detection. And basically what that means is that as my switches and routers start to become congested, I'm going to look at the packets and I'm going to decide based upon the priority in the packet whether or not I should keep or drop a packet. Tail drop means, you know, hey, my buffer's full, I'm just going to drop packets. I'm just going to drop packets. And that's pretty bad for PC over IP. We need the packets to arrive at least occasionally. And then PC over IP can dynamically adjust. Finally, my strong recommendation to customers is to use quality of service. It's not that difficult, especially for customers who've already implemented PC over IP. Voice over IP. They've already figured this out. Just add one more rule to your switches and routers. Let's make PC over IP one step below voice over IP so we don't disrupt any voice communications. And so the last bit of advice, it's career advice from me. If you think I did a good job or a bad job, we'd really love to hear about it. And so make sure you fill out the survey for the session. I think we're just about out of time, but if you have any questions, I'm going to be hanging out up front. Thank you very much for attending.